Welcome to Curve Sketching Steps Part 1. This video is an extension on the last video where we found the asymptotes, and we're going to include finding our x and y intercepts and any other significant points. And we're just going to sketch. It doesn't have to be accurate, but it's got to obviously show as many features as possible. So the suggested steps, and this is pre-calculus, so before we get into finding turning points. You add or subtract fractions if it's necessary, and then factorise, because that's going to help us find x-intercepts, y-intercepts, asymptotes. Then you find the domain. You determine if the function is even, odd, or neither. X and y-intercepts using y equals 0 and x equals 0, respectively. The sign of the function, we did that in a previous video. And then you find the asymptotes. And today we're going to look at, well, how does the function behave near the asymptotes? So our two examples are going to be 3x squared over 16 minus x squared and 1 over x minus 1 plus 1 over x minus 5. So for our first one, so the first step was to factorise. So you can see there we've factorised the bottom, or the denominator. So that gives us a domain because x can't equal to 4 and minus 4. So we've got the domain is all x values except for 4 and minus 4. And that gives us the domain that we've written there. Check the symmetry. And if we sub minus x in, where there's an x into the original function, you see we get the original function back. So that means it's even, meaning it is symmetrical over the y-axis. Next is to look at the sign of the function. So firstly, let's find our x and y-intercepts. So when x equals 0, y equals 0. So that gives us our important values to put into our table. So we put the minus 4, the 0 and the 4 in first, and then we pick a value either side or in between those values, and then sub it into the function. So if I sub minus 5 into the function, I get minus 8 1/3. Subbing minus 4 in, I don't get a solution because obviously that's an asymptote. If I sub minus 2 in, I get 1, so that's a positive. 0 gets me 0. Subbing 2 in gets me 1, so another positive. And subbing 5 in gets me minus 8 1/3. Check for horizontal asymptotes. So from our last video, we divide by the highest power of x in the denominator. So in this case, divide everything through by x squared, and you get 3 over minus 1. So there is a horizontal asymptote at minus 3. So it's easy to check either side of our asymptotes because at minus 4, we just sub a number in just to the left and just to the right. So minus 4.001 and minus 3.999. If that's not giving you enough, just add another 0, another 9, and substitute it in. And the same either side of the 4. If I want to see what's happening on the horizontal asymptote, I need to sub in a really large negative x value and a large positive x value to see what happens. And this is how our graph operates. So we had 0, 0 was our was where it touched the axis, and it was positive to the left and positive to the right of that 0. And on the opposites, on the sides of the asymptote, it actually approached positive infinity on both sides. And then down in the bottom, and you can see that this is an even function, so it's symmetrical about the y-axis. As you can see, it approaches the horizontal asymptotes from the negative side. So when you subbed it in, you should have got minus 3 point and then, just a little bit higher for both sides. And it approaches minus infinity on the either side of minus 4 and plus 4. Okay, here's our next one. So for this one, to assist, it's going to be helpful if we actually add the fractions, because we can definitely tell where our asymptotes are, because x can't equal to 1 and x can't equal to 5, but we need to know what's going on the numerator. And so when we add them together and then factorise, we get 2 outside of x minus 2 over x minus 1, x minus 5. So we obviously have asymptotes at 1 and 5. So therefore our domain is the complete. It is all of the x values, but just not at 1 and 5. So that's how our domain comes about. To find the symmetry, it's best to expand and then actually substitute minus x in. So when we expand, we get our function is 2x minus 4 over x squared minus 6x plus 5. Now, to be even or odd, I've got to get back to that function. So when I sub the minus x in for where there's an x, I don't get the original function. So it's not even. When I then times it all by a minus, so I'll do it, put the minus on the numerator, I don't get the original function back either, so it's not odd. Therefore, it's neither. So therefore, it's not symmetrical about the y-axis, and it's not rotational about the origin. Check of what happens with the sign of the function. So let's find our x and y intercepts. So when x equals 0, y equals minus 1.2. And when y equals 0, x equals 3. So that tells us where it crosses each axis. There's a 0 at x equals 3, and the vertical asymptotes are at 1 and 5. So that gives us our points, 1, 3 and 5. At 1 and 5, they're asymptotes, so we've got no values in there. We've got the dotted lines there. So, because it can't equal to 1 and 5. And then we check the signs by substituting into the original equation to see what happens. Horizontal asymptote, divide by the highest power of the denominator, which was x squared, and you get 0 over 1, which is 0. So y equals 0 is a horizontal asymptote. So that means it's going to approach, the graph is going to approach the y equals 0 or the x-axis. Once again, check the behaviour by substituting values either side of your asymptote and large values of x in a positive and negative direction. And that's how our graph looks as we sketch it. Thank you.